Here we go. Second half of section 14.1. Now we're going to graph the tangent functions. Now before we move on to tangent functions though, I wanted to go back and do one problem that has both an a and a b in the cosine, function. So if you'll remember, the amplitude is found by the absolute value of your a value. So the amplitude of this one is 3. And the period is found by using the b. If you'll remember, you're going to take 2 pi over the absolute value of b. So 2 pi over 2. So now when you simplify this complex fraction, remember you flip the bottom one and multiply. So times 2 over pi. So when you do that, the pi cancels and we have 4 is the period. So this means that the height is going to be up to 3 and down to -3. That's the amplitude. And then the period is how long it is. And so this is going to be 4 long. So we're going to go 1, 2, 3, 4. Okay, so, oh, and I should have spread them out a little more, but that's okay. So what we're going to do with cosine, remember, cosine starts and ends at the amplitude. So we're going to start at the amplitude. And at 4, we're going to be back. So 1, 2, 3, 4. At 4, we're going to be back up to, that's going to be 1 period. And then halfway there is at the 2, and that's going to be at our minimum. And then at the 2 halfway between the halfway, so at the 2 1/4 marks, we're going to go through the origin. So that would be the cosine, 3 cosine pi over 2x. So you will have some problems where you have sine or cosine that have an a and a b. I think in the last section you only had one or the other. All right, now we're going to involve the a and the b in a tangent function. In a tangent function, the parent function looks a little bit different. Remember, the sine and cosine had the same curve. They were just kind of shifted. Well, with the tangent functions are going to have asymptotes that are pi apart. So what we've got here is we've got a domain of all real numbers except the odd multiples of pi over 2, which are the vertical asymptotes. So if you'll look, the domain, remember, is the x, and x's, you've got all of the x's except where you have these asymptotes. So the domain is just pretty much anything except those odd multiples of pi over 2. The range is all real numbers, okay? Instead of having a high and a low, a minimum and a maximum, you're going to go on and on forever, positive and negative. And therefore the amplitude, there is no amplitude because there is no minimum or maximum. There's no amplitude, there's no top part or bottom part. And the period is from one asymptote to the next, which in this case is pi, is the distance of pi. So you're going to go from negative pi over 2 to positive pi over 2 is one period. So remember, a period is one set of things that are going to be that are going to repeat over and over again. All right, so we have our formula, or our function, y equals a tangent b of x, and we'll find the period. Because the period in our parent graph is pi, what we're going to have for a period now is just pi divided by the absolute value of b. All right, and that's going to be different than the sine and cosine. Remember, the period was 2 pi long. So this is just pi divided by the absolute value of b. And the vertical asymptotes, we're not going to find an amplitude. There is no such thing in a tangent graph. But the vertical asymptotes, the way you'll find those are they're going to be the odd multiples of pi over 2 times the absolute value of b. All right. Now, one other thing that you need to know about the tangent graphs, at the halfway points between the asymptote, or between the x-intercept and the asymptote, at the halfway point, the y value is going to be either positive a or negative a. So that's where the value of a comes in. Okay. Let me show you. All right, So the period is going to be found by pi over b. So we've got y equals 2 times the tangent of 1/2 x. So the period is pi over b. So the period is pi over b is our 1/2. So pi over 1/2. So when we flip and multiply, this equals 2 pi. So in this case, our period is 2 pi. So that means because we're going to go through the origin with this one, that means we're going to have a period of 2 pi, which means we're going to go backwards and forwards 1 pi. All right. The asymptotes are going to be the odd multiples of pi over 2 times b, which is 1/2. So 1/2 times 2 cancels out. So our asymptotes are at pi. So they're at the multiples, the odd multiples of pi. So we've got an asymptote at pi and an asymptote at negative pi. And so there's our asymptotes. And the halfway points between are going to be pi over, the halfway points between pi and 0 are pi over 2. So that is going to be, and then the y values are going to be plus or minus 2. So we've got 1, 2, 1, 2. All right, so there's plus 2, and this is minus 2. Okay, here we go. So now, halfway in between, we're going to be at this point, and halfway in between here, we're going to be at this point. And so we're going to go toward our asymptotes, but not cross them. So we're going to go through the origin, and there's our graph, and that's it. Okay, so the only thing you've got to do is you've got to find how wide is it. Well, this is 1 pi, 2 pi long, 2 pi wide. You'll find your asymptotes by using the your formula there, and then find the how far up or down is your point at the halfway points, and that's it. And you're going to have that same shape every time. All right. That's all there is to it. If you want to do 1 or 2 more to the right or to the left, you certainly can. And so in this case, you're going to go all the way to, you're going to go over another pi this way and that way. And actually it's odd multiples, so it's going to be 3 pi instead of 2 pi. And then that would be your interception would be at 2 pi because we've got the odd multiples. Okay? All right? I think that's it. That was quick and easy. Oh my word. Surely I can teach you something else on this. I guess not. You've turned me off already by now anyway. I think that's it. Tangent functions. We're coming to the end of the year. Hang in there. Keep working. See you soon.